All right, what do we got going on here today? So we have a file to download today. That will be almost always be the case for the rest of the semester. So go to the blog today, download ISBN2. It's an XLSX file, which means there's no code in it yet. So you don't have to unblock it, but you make sure you save it as an XLSM file. And we're just going to follow this link to look at the ISBN page at, oh, you know what? In fact, before we go there, let me just make a new sheet here. And we're just going to suppose for just a second, we turn this into the 1970s. Let me select all these cells. We're going to make a computer interface that the 1970s would love. Select everything. And make this black. And make this dark green, light green. And let's make this even Courier. We do Courier. All right, welcome to the 1970s. Do I remember the 1970s? I was born in 1968. I remember the 1970s. Delete columns. So let's suppose, it's mid-1970s and you are manager or director of a bank. In the 1970s, is it possible that you could have a bank? You could run a bank in 1970 without a computer? Yeah, in 1970, you could have a bank without a computer, but you're probably we should be thinking about these so-called computers. In fact, here's the reason. So do you know how we used to calculate interest on accounts? This seems absolutely absurd to us today. Once a quarter, we would close the bank, like a normal work day, and the bank is closed to customers. Why is it closed? Because everyone who works for the bank is busily accruing interest. They're going through the paper files and they're keeping track and they're calculating how much interest has accrued on that account during that month, and they're writing it into the ledger book. And so it's tremendously labor intensive to keep track of interest. And so maybe if we can get computers to do this, that'd be pretty good. So let's suppose that you're getting a computer, and we're going to do the simplest transaction possible. We're going to design a screen here to help us do a cash deposit. So what information do I need to collect to be able to make a cash deposit? What information, to do this, what do we need? We need an amount, AMT. We abbreviated everything in the 1970s too. And maybe we could do something to make this look like it's a field here. So maybe I'll actually make this part green. One thing we could do, we could make that green and we could make the text black on this part. Okay. So place that we could enter in an amount, right? Okay. So there's no mouse involved with this. It's just characters. And you got two colors. You got green and black to work with. That's it. Okay. We got an amount. What else do we need? An account number. Got it. You guys are good at this game. ACCT number. If I've got that information, I can successfully do a cash deposit. That looks great. What are the risks with entering this data? What are the real potential problems here? Now, and we got to kind of figure out how to. I'm setting the background for what we're going to learn today. So we're keying this stuff in. We want to make sure that it's keyed in right. That's a really important thing about banks, is that the records have to be right. It's not like you've got a little box in the back where we put your cash to hold it for you. We put it in a big pile of cash and we lend a bunch of it out. We got to keep track of how much you deposited so we can give you back, just exactly what you gave us, maybe plus some interest. So, what are the risks here? Now, here's the expensive part. We got to figure out how to validate this data, and to do it without the two really expensive computing operations that we take for granted today. And what are those two really expensive operations? The first one is telecom. So making a request across to a different location, to a different branch, crazy, crazy slow and expensive for us to do. And the other one is even so network is really slow. and expensive. And the other thing that's really slow is reading like disk, like reading information off the disk. We take that for granted today. It's really slow. So we'd like to figure out a way to validate this information without having to do either of those two operations. Any thoughts? What are we going to do? Yeah, go ahead. Yeah, so if you're, yeah, we're not making a new account. That's right. Okay, so you could check to see if it exists. Like, is that really a valid number? Is that a valid number? Only problem with that is it takes this. We got to read the disk to do that. Yeah, we'd like to see if we can do that without avoiding that. Now, and just checking to see if it's valid would be a problem, because if this is my account, and someone does like a common thing, like transposes two numbers, puts in the 5 first and then the 1 first and then the 5, still a valid number. And so that's probably like checking to see it's going to be expensive, and it's not really going to give me that much to be sure that it's valid. So I don't like it. Thank you for volunteering it though. It's the 1970s. Look, we had bell bottoms, we had afros, we had polyester clothing. It was a great time. So other thoughts on what you might do? How could you validate the amount without having to do like any disk or transaction or any network? I'm not sure how disk or network would even help for that. The good news is that the person who's making the amount knows the amount th're depositing. So like that person can verify the amount. You can type it in, read it back, or even display it to them. Although we're not really showing, it seemed kind of garish to let someone even know that we had a computer in the bank. And so we're probably not going to display it to them, but we're probably going to get the amount right, because the user is going to help us do that. But the user, they may know their account number, they may not. If they don't know their account number, we're going to have to look it up. There's just no way around it. But if they provide the account number, we just want to make sure that it's typed in correctly. So any thoughts about how we might make sure that it's typed correctly without network or disk access? Man, it's tough to think in the 70s. We didn't do a whole lot of thinking anyway, but yeah. Type it in twice. In fact, that's a way that we still use today to do it. Typically, when we're doing double entry to make sure that things are typed in right, we have two different people doing it. So the problem is, if one person's doing it, if the error happens on output, but if they type it wrong, that'll catch it. But if they read it and the transposition happens when they're reading it, then so that's going to help, but probably not going to be our best bet. And in the 1970s, they invented something new called the check digit. Have you heard of it? Yeah. Okay. So this is what they did. They said, look, if our account, let's say our account, is this, how many digits do we have up here? 6 digits. Let's say our account is 6 digits. What we're going to do is we're just going to number our accounts. So we've got, account number 1,000 or 420. We got account number 400,000, and then what's our next account number? 400,001, and the next one 400,002. They just count up like that. And so what they said was, listen, what if we did this? What if I guess I'll do this in the 1970s as well. What if we said, we're going to look at this account number, and what we'll do is we're going to sum up the digits. And so we're going to look at this and we're going to say, this is equal to 4 plus 2 plus 1 plus 5 plus 1 plus 4. 4 plus 2 plus 1 plus 5 plus 1 plus 4. I don't know. I don't really care if I got it right. We say 17. And so what we're going to say is the real account number now is that. So we've got a portion of the account number that is the numeric identifier for the account. And then we've got a little bit more that we type in each time that allows us to see if we typed it in correctly. Because now what we'll do is now we can type in these, let's see, 8 digits, and then without having to hit the hard disk or having to make a network call, we can sum up the first 6 digits and see if they sum to the last 2 digits. So in fact, this algorithm here is what's referred to as a checksum. It's called a checksum because it's just the sum of the digits. And so now, if I make a mistake typing this number, then I would have to make, like in the first 6 digits, I would have to make a counterbalancing mistake in the last 2 digits for this to be like erroneously typed as a valid number. And the likelihood of that happening is extremely low, except in one case, which happens to be the most common typographical error when you're typing numbers. What is it? Transposing 2 digits. If you transpose 2 digits, the sum is going to be the same. And so some very smart people in the 1970s, there were a few, they were like, you know what, maybe we could do something that's a little more sophisticated in math that would prevent against, that would also be able to tell if we have any 2 consecutive digits transposed as well, and have that then, you know, kind of fail the thing. And that was then, we went from something called a checksum to a check digit. And the idea behind a check digit, a good check digit algorithm is going to be, it can protect against any single number being typed incorrectly, and it can protect against any 2 sequential digits being transposed, and we can do it with only 1 extra character having to be typed in. So the checksum was 2 characters typically, and this you could do with only having to type in 1 additional character, and that's why it's called a check digit, because it's 1 digit that's used to check the validity of the rest of the information. And check digits are used everywhere today in numbers. Anytime you've got a number that like has to get typed in to identify something, I guarantee you that there's a check digit built into it. You know, unless it's like something that you made, you wouldn't have known to do that. But you know, like the real thing that the systems, they always have these check digits. Has anyone like worked in the book industry? You know, like you're like ordering, selling, buying books. Anyone? No. Okay. So that's one of the places where we routinely type identifiers, because we type in ISBNs all the time. So International Standard Book Numbers to identify the books that we're talking about. And so what our goal for today is to build a function that we could just put into a cell in Excel that would validate a 10-digit ISBN. It would let us know if it's a well-formed number or not. Now, of course we can't tell if it's really a book, if there's a book that has that number, but we can tell if it's a well-formed ISBN. We're going to do that by using the calculation that we see here at Wikipedia dealing with check digits. So there's a whole thing on ISBN numbers, kind of, you know, what you can tell from the different parts of the number. In fact, like here's the, this tells what kind of product it is. There's only a couple of different values that are legal for books here. Part of this will tell you who the publisher is and so forth. But what we're going to do is we're going to implement this algorithm here, which is how we can tell if it's well-formed. So that's our goal for today. But while we're right here, I thought I would share an interesting story about a guy who I refer to as my former colleague, although I was never an employee of BYU at the same time. This is a guy who was, you know, a faculty member at BYU. Have you heard of him? Frank Abagnale Jr. Anyone, you know, recognize that name and you go, oh, I know that guy. And you might be going, really? He was a BYU professor? Who was Frank Abagnale Jr.? He's a con man, and you know, they wrote a book and a movie. Yeah, catch me if you can. I got to tell you, if they make a movie and they hire Leonardo DiCaprio to like play you in the movie, that's pretty good. So he doesn't look at all like Leonardo DiCaprio. So you know, he was like one of the most gifted financial instrument fraudsters ever. And his, you know, the big thing that he did was, you know, he would pass himself off like as an airline pilot, and he would fly around the country for free. The whole reason he wants to fly is so he can go to different towns and kind of use his persona as an which you get a lot of trust being an airline pilot to cash checks that would never clear. And so, you know, he'll take a flight to Miami for today and go cash a bunch of checks and then disappear. So, but his very, very first financial instrument fraud dealt with this, with the deposit mechanism. And so what was it? He noticed that, and they're probably still around to this day, but when you go to make a deposit, now today, usually when you go to make a deposit, how many of you like are going, I've never been to a bank to make a deposit? Anyone going, you know what, I've just never done that? Oh, wow, most of you. I've got some of my younger classes that are like, there's some people like, yeah, I've never done that. They do everything electronically. And that's probably the way you are now, mostly doing your banking, on your app and whatever. But you can still walk into a bank and make a deposit. And it used to be that, if you're going to make a deposit, you have to fill out a deposit slip. Well, you've got deposit slips pre-printed in your checkbook, but if you don't have your checkbook with you, they've got them sitting on the counter. You can just pick one up and you can fill in your account number if you know it. Or if you don't know it, they'll look it up for you when you go make the deposit. So if you can put out the cash and the checks and everything with it. Well, he noticed that people who didn't know their account number would just fill it up and they would take it up to the cashier or the teller, and the teller would look up their account number. But if their account number was already in there, the teller would just key in the account number and move along. So what did he do? He went in and he picked up a stack of those counter deposit slips, took them back home to his apartment. He rolled them into a typewriter and he typed his account number onto the paper. And then he took those back into the bank and put them back on the counter. So when Edna comes in to deposit her Social Security check, she would take his account, fill out all the information like she always did. She never knows her number. And then the teller would see the account number deposited in. And after a couple of weeks, he withdrew the money, closed the account, went away. So ultimately, he's going to get caught. What does he do now? Did anyone know what he does now? Yeah, he works for the FBI. He may be a contractor for the FBI, but that's the main thing he does is he works to catch other financial fraudsters. He's really pretty good at it because he thinks he's still pretty smart at this stuff. The biggest contribution to financial instrument fraud, was he found out that if you printed a check, how at the bottom of the check, it's got that magnetic encoded ink where the numbers are all shaped funny. Have you noticed those? Like the bottom of a check, they got these funny shaped numbers. That's because that ink is magnetic. And so it can actually read those numbers and route that check to the right point. The right place. Well, he realized that if you printed checks and the routing number at the bottom, sent the check to the wrong end of the country to be cleared, we used to actually send paper around for them to clear, that it would take a month for a check to bounce. How would you know if you're a bank in the 1980s, 90s, early 2000s even, how would you know that a check bounced? How would you know if a check cleared? If there was enough money for that check to clear, how would you know? This is amazing to me. The way that you know a check clears is that it didn't bounce. We send the check out, we kind of put it with all of our checks, we send it to this clearinghouse and it routes them all back to the original places. And if it makes it back to the bank and there's not enough money for that check to clear, they stamp it NSF, non-sufficient funds, and they send it right back to you. That takes about a week. So tell me, have you ever made a large deposit and they said, there's going to be a hold on these funds for a few days? Has that ever happened to anyone? So there's a few of us that have done that. And that's because they're checking to make sure that transaction really does go through. It doesn't take as long as it used to. They're going to make sure it goes through before they release those funds to you. Well, the only way that you knew that a check bounced is that a check cleared is if it didn't bounce. And so he had made these checks that would take a month to bounce because, they would be they clear in San Francisco, they get routed to Philadelphia. And in Philadelphia, this check doesn't belong here. What would they do with that check when it shows up in Philadelphia and they realize this thing belongs in San Francisco? What would they do? They'd put it back in we don't know how this got here, but we're going to put it back and we're going to send it to get routed again. And what would it do? Come right back to Philadelphia. And it would take about a month before we finally realized we got to do something with this and scribble that out or do something and send it back through a different mechanism. So we would come in, open an account, dressed like an airline pilot, deposit all kinds of money into this account. After a week, it's cleared. They think it's cleared because the checks haven't bounced. And then he'd withdraw the money and disappear. And in the book, catch me if you can, doesn't make the movie, but in the book, he claims to have gotten a job as a professor at BYU in the psychology department and taught here for a few semesters. What's that? Sociology, yeah, sociology department. Did you have him as a student? Yeah, you have been pretty young. Yeah, probably not. Anyway, so the university, by the way, denies it. I don't know who to believe in this situation. BYU says never happened. Anyway, all right. But let's go ahead then and take a look at the calculation for the check digit. This is the algorithm here. So this is the one page in the workbook. So suppose we have this 10-digit ISBN. Whatever that number is there. The first 9 digits are what actually identify the book, and the last digit is the check digit. So here's what we do. We take each digit and we multiply it, starting with 10 and going down. So the first digit we multiply by 10. The second digit we multiply by 9. The third digit we multiply by 8. Are you seeing how this works? Finally, to the last, to our last digit, we multiply that one by 2. We sum all of those up, and that gives us like the first step in calculating this check digit. We then take that mod 11. What does it mean to take something mod 11? Yeah, we divide by 11 and we take the remainder, right? You're going back to like 5th grade when you learned how to do long division. What does this mean? That means that if I take the number 236 and divide it by 11, then I can cut that up into 11 pieces, all the same size. No, I can cut that mod 11 divided by 11. If I divide that by 11, I can cut it up into, we don't see the answer here, but some number of pieces that'll have 11 in them, and then I've got 5 left over, a remainder of 5. That's the next step. Then I take 11 and subtract whatever that value was. That gives me 6. Then I do it one more time. I take that number, mod it by 11, and again, I have 6 here as the result. Now, if I take something mod 11, what are any number, like a random number mod 11, what are the possible outcomes from that operation? Could be evenly divisible by 11, so there'll be a remainder of 0, or it could be 1, 2, 3. But what's the maximum that it could be? Yeah, 10, because if it was a remainder of 11, it's not a remainder. You got the quotient wrong. You should have one more in the quotient. And so the result could be anywhere between 0 and 10. Now that's 11 different characters, 11 different values, and we've got to be a check digit, it's got to be a single digit. So we've got to figure out a way to represent those 11. Well, 0 through 9, I can represent with the symbol 0 through 9. But how am I going to represent 10 as a single digit? How can I say 10 as a single character? Is there a question or a comment? Presumably, there must be a situation where it would, and I don't know. I'm not entirely sure that I wrote this correctly. I am sure that this one is right. Does it have that in there? So if we look here, we're taking that whole sum there, summing that up to 130, taking 11 minus 30 mod 11. Looks like we have 2 mod 11 operations, mod, yeah. So I think they're in there. I don't know. Now I forgot the question where were we? We were just, how can I show the quantity 10 as a single character? What's that? Roman numerals happens to do that. You guys learned this probably in 3rd or 4th grade or something. You learned your Roman numerals. So X means 10. And so if you ever look at, now today, books that are newly printed today, there's a new numbering scheme, a 13-digit ISBN. And the reason they went to 13 digits is because it brings it into the normal product space. So the first 3 digits of an ISBN today now say, this is a book. And then the rest of it is your ISBN. So, and 13-digit ISBNs, there's no X involved, but a 10-digit ISBN can have an X as a check digit. And if you've ever worked in a place where you have to type in ISBNs, they have special keyboards that have a 10-key pad. It's actually 11 keys because it has an X on it, just so you could type that X without having to go to the rest of the computer. So our goal then today is to be able to create a function that will allow us to implement this algorithm, and so that we can use it to verify if we've got valid ISBN. You ready to do it? Let's do it. No, I'm not ready. Tell us a few more stories. It's been kind of a story-laden day. All right, Alt F11. I'm going to insert a module. And it looks like I took off my properties and my, what is it called? Object browser, Project Explorer, there we go. To look a little more familiar to us. Okay, so I've got a new module, it's a general module. And let's just go ahead and make a function. Remember, I think we did like one example of making a function when we were talking about something else. I don't remember what it was, but function, F-U-N-C-T-I-O-N. So function, I'm going to give it a name. I'm going to call it is valid ISBN 10. And hit enter. Now, it's going to put in these parentheses here. I think we might have even seen what we use these parentheses for. The one thing I'm allowed to do inside of these parentheses is what? I can declare a variable. It's a special variable called the parameter when I make it, but it really is a variable. And because it's the only thing I can do in there, not only do I not need to put the keyword dim, I'm not allowed to put the keyword dim, but the rest of the syntax is exactly the same. So I'm going to accept a value into this function to be validated. And what am I going to do? I'm just going to call this the candidate. I'll take that in as a string. Definitely have to be able to deal with not just numbers for a couple of reasons. First of all, it's possible to have a 0 as the leading digit on an ISBN. And if I take it as a number, I'm going to lose that leading 0. Because representing as a number, all we know is the quantity. We don't know how many zeros might be in front of it. And of course, we can have an X is possible in here. So I'm going to accept that in that what I'm going to validate. And then who can remember what we have to do to say what this function returns? To tell this function what to return, what do we do? That's right. We take the name of the function and we set it equal to something. So I'm just going to set this equal to true. This thing is going to return true or false. In fact, I would like to signal to the user and to the system that it's going to signal that it's going to return only true or false. Functions, because they return a value, they can have a data type the same way that a variable can. And so here, where I'm declaring my function, I'm going to put right after this as, and then I can give this a type as well. So by making this a Boolean type, we are saying the only thing this can return is a 0 or a 1. And in fact, if I return something besides a 0 or a 1, it's going to be an error unless it can convert that. So I return, I'm sorry, when I say Boolean, true or false. So if I return any numeric value, VBA can convert any numeric value to Boolean, because if it's 0, it's false, anything else is true. If I return like a string that says true, it'll go, oh, you returned a string, but you mean Boolean. It'll do that conversion for me. But right now, this function is working. It's not a very interesting function because it always returns true. But let me just go ahead and like call this function. So is valid, you have it on my clipboard, is valid ISBN, and I'm going to pass it in a string. I'm going to go ahead and pass in the example that we're going to work on over here from Wikipedia. And looks like the remainder of that is 2. So I'm going to pass this one in. That's the ISBN that I'm after. And so now if I run that, that'll tell me it's a valid ISBN. But of course, if I change any one of these or put an extra digit on there, it's still telling me that it's valid because all this thing does is return true. And of course, I could call this from inside of a worksheet. I think we saw that before. We can call it from a worksheet as well, call it from other code in VBA. So step one, what I'd like to do is I'd like to say, listen, I only want to deal with, if there's some character in here that is not possibly a part of an ISBN, I want to get rid of it. I don't even want to consider it. I want people to be able to put spaces in their ISBN, put hyphens in their ISBN, put dots in their ISBN, put slashes in their ISBN. Those are all normal ways to kind of represent the different segments of an international standard book number. And I just want to ignore them all. So what are the possible valid characters in an ISBN? So numbers and X. So numbers and X are it. So what I'm going to do is like step one, I'm going to say, look, let's just get this thing down to the valid numbers. Reduce to valid characters. So to do that, I think I'm actually going to want to write another function here. I'm going to call this valid characters. Valid chars. Hope I'm working in the right language here. And so I'm going to send some data here as a string, and this thing is going to return a string. And we did something earlier where we did something that was just like numbers only. I think we did another example. This is going to be really similar because it's going to be, numbers or X is what's going to be valid here. So I'll go through this kind of quickly because we've seen most of this once before. So let me dim X as an integer. Let me dim temp as a string. And let me dim one char as a string. And what we want to do is we just want to loop across whatever gets sent into this. So it might be helpful for us to kind of think about what the call to this looks like. So I'm going to call it this way. Print the result of valid characters, and I'm going to send it down this potential ISBN to work on. it's going to accept that value into this variable as data, and I want to be able to look at those one character at a time. So, fantastic. I'm going to say for x equals 1 to the length of whatever got passed into me, data. I'll put next in here. I'm just going to go ahead and say, I just want to deal with one of those chars. So like one char is going to be equal to the mid of data starting at the x position and taking one character. And so I'm looking at the middle of whatever got passed down here. When the first time through this loop, x is going to be 1. And so I'm going to start at the first character. I'm going to take one character. That's what's going to be one char the first time through the loop. Second time through the loop, this hyphen will be the character that I'm considering. So now we just need an if statement here. If one char, whoops, I'm going to call, we'll do this. If one char is equal to x, now I think I'd be okay with them typing it in either lowercase or uppercase. So I could say if it's lowercase x or uppercase x, or I could just say, you know what, let's just call the lcase function around one char. So lcase just takes whatever is sent to it and returns back the lowercase equivalent of it. So I'm going to look at that character, and if the lowercase version of it is equal to x, or it's numeric, then E-N-D-I-F, then that's a keeper. So I'll say temp is equal to what it used to be and concatenating on one char. I do. X will always be numeric. In numeric is numeric one char. Thank you. It is numeric. So the lowercase version of one char is x, or x is numeric, it's a keeper. I'm going to set temp equal to what it used to be, concatenating that on, and that's it. That'll loop through and only accumulate the characters I want here in x. And so now I'm ready to set the return value of this function. Valid chars equals temp. And so if I run this function from the immediate window, it'll now give me just the characters that are allowed to be. If I put an x here, then that should come back as well, because x is allowed. And whether it's uppercase or lowercase, should be all right. Questions? Okay. So my next step now is going to be to actually capture this version of the ISBN in my main function. I'm going to create a variable here. I'm going to just call this one ISBN. And that'll be as a string. And I'm going to set it equal to valid chars. And I'm going to pass it the candidate. So whatever gets passed in for me to evaluate here, I'm going to say step 1, let's just go ahead and throw away anything that couldn't possibly be part of the valid ISBN. And so, valid chars will go do the work on that, and I will have then this value sitting in this variable ISBN. At this point, there are many thousands or hundreds of thousands of entries that people could type in that I can just very quickly at this point say that can't possibly be right. That number is not valid, without doing any of the algorithm that we see over here at Wikipedia. What could I do at this point, like right here? Say, I'm going to put the comment in, and you're going to tell me how to do it. I'm going to say, check to see if this even could be remotely possibly valid. At this point, what simple check could I do to say, you know what, that can't be valid? Yeah, the length. It's a 10-digit ISBN. And so at this point, if I don't have 10 digits in ISBN, it is not a valid 10-digit ISBN. It could be a valid 13-digit ISBN, but that's not what we're checking. 10 digits only. So here's what I'm going to do. I'm going to say, just put an if statement here. If, whoops, did I put parentheses around my if clause? In many of the other languages I work in, you have to put parentheses around what's in the if clause, and I sometimes do that, but I didn't do it here. I just want to make sure I'm not giving you the wrong syntax. If the length of ISBN is equal to 10, I don't want to know if it's equal to 10. I want to know if it's not equal to 10. I've got a couple ways I can do that. I can use the keyword not right out here. Not just returns the opposite of a condition, a logical expression, just a true or false value. So if I come here and say not true, that'll tell me false. That's pretty good. What about not true? True. Like you could get confusing here, but you could like reverse them all. So not just, returns it. So not 1 equals 1. Let's go back to just one not here. Not 1 equals 1. 1 equals 1, true or false statement. Yeah, 1 equals 1 that's a true statement, and so that's going to give me false. Okay, so not just says whatever it's operating on is just going to reverse true to false. So that's a possibility. Or another way that I can say not equal to is with a comparison operator, like a less than, greater than sign. That also means not equal to. This is probably the more common way to see it, using the not equal sign, the not equal operator. Okay, so at this point, if it's not, then what I'm going to do is I'm just going to say exit function. In fact, because it's only one statement, I'm going to put it up here on the same line. I don't even need the end if. If the length of my ISBN at this point is different than 10, it can't possibly be right. Now, every single data type has a default value. When you create a variable of a particular type, it's going to get initialized to that default value. All strings are initialized to an empty string. All numeric types are initialized to 0. What do you think is the default value for Boolean? True or false? Which one do you think it is? Yeah, it's false, because that's the equivalent to 0. And so it defaults to false. So unless I set it to true, this thing is going to return false. So I haven't, at this point, I've come through, I've never set the value, I'm just exiting the function. It's going to return false. So let's just go ahead and check it. So I'll do this one here. There's my is valid ISBN. And that tells me that it's true, just based on the length. If I extend the length here with a number of characters, that'll now tell me false. Because now it's boiling that down to 11 characters and it's failing this first check. What happens if I put here like a letter? A, is that going to be true or false? This is going to be true because step 1 is throw away everything that's not a number or an X. And so A gets thrown out. I'm not sure I really like validating that number, but that's the algorithm that we're going to apply right now. We could make it a little more sophisticated and only say, well, there are only some things that we're going to allow to be the delimiters, but right now we're saying anything that's not a valid character, we're going to throw away, and that's okay. All right. So now I think at this point, the nice thing at this point is that right here, now we know that the length of ISBN is 10. Knowing that we've got exactly 10 characters here is going to make our code now a little bit nicer to work with. We don't have to check to see if we're looking past the end of something or whatever. Okay. Whew. So now here is our next task, is to do this first step. Is to take our first digit in the ISBN, multiply by 10, add it to the next digit multiplied by 9, add it to the next digit multiplied by 8, right? We see these 0, 0, 3, 0. Yeah, so 0, 3, 0. Those are the 3 first digits, and we're multiplying it by that. Now, it might be tempting to just say, well, that's just a long expression. I can write that all in one expression. Like I could write a mid function that takes off the first character, a mid function that takes off the second character, multiply that by 10, multiply it by 9. But what I'd like to do is I'd like to give us a little bit of practice using a loop here. So I like to do this with a loop. So let's go ahead and create something that will kind of accumulate those values. So instead of doing all of these in one step, I'm going to do the first one, and then I'm going to add on to that the result of the second one, and then add on to that the result of the third one. We'll do that with a loop. So I'm going to declare a variable to hold reduced to valid character. I mean, with this comment here, and I'm going to create a variable to hold that summed up value. So let me call that checksum. And we'll do that as an integer. All right. Now, rather than, actually, let me go ahead and declare x. I'm going to use x to control the loop for me, dim x as an integer as well. All right. So rather than try to work with the loop here, I'm going to show you a little trick that I use when I'm working with something that's kind of difficult to think about. How would I write the loop for this? And for most of you, doing anything with a loop still feels a little bit difficult to think about how the algorithm is going to work. And so what I'm going to do is I'm just going to write, like of the statements I'm going to try to write in the loop, I'm going to write 3 of them. I'm going to write them out all the way, so I can kind of see the pattern. I can see what's different as I do the math, and then it'll help me see what do I have to do to be able to convert that into a loop. So I'm going to say checksum equals. So the first thing I'm going to do is I'm going to set checksum equal to the mid of my ISBN, looking at, starting at character number 1 and taking 1 character. And I'm going to multiply that by 10. Is that what it does? Yeah, 10 times the first character. Now, the next time through, or the next thing I'm going to do is I'm going to say now checksum is going to equal what it used to be plus mid of ISBN starting at 2, taking 1 character and multiplying that by 9. Next one is going to be looking at the third one, multiplying that by 8. So I'm going to do one more here. The next one is going to be the 4th character, taking 1 character, multiplying that by 7. Now, it's really easy for me to see that this is a really simple pattern. I can make a loop around here that has some integer that's counting, because this one's counting up, this one's counting down, a little bit of simple math, and I could have those all happening, with one statement. This one looks pretty different. I got a couple of options. I could do this outside of the loop and then just do the ones that are the same in the loop. Or could I modify this one somehow so that it would still work using the pattern of the others? And the answer is that because checksum is numeric and it starts at a value of 0, the only difference here is that we're adding on checksum. So the first time through, even if I add checksum on, it's not going to change its value because 0 is the additive identity. You add 0 to any number, it doesn't change the value of the number. So that looks pretty good. I can make a loop that will execute those 4 lines, or I should say those 9 lines, without having to write them out all individually. So let's just go ahead and do that. Anyone want to take a stab at it? You might be sitting there saying, you know what, we're paying you to do this for us. Like, you want us to, it's kind of like going to the grocery store now. Like, you got to check out your own groceries. Didn't even know I was working there. Okay, if someone wants to take the challenge, go ahead. Okay, so what you're saying is you're going to use a variable for this one. You're going to say I. So you're going to want some way to make a variable named I. Let me go change I'll change it to I, since you said I, captain. I'll make it lowercase because that, I can't tell if that, in my font, I can't tell if that's an L or not. So caps lock off I. Okay, so what am I gonna do to make I count? For I equals 1, 2, 9. Good. So you got the for next loop. The for next loop is totally just designed for this kind of thing. It happens so often that we made a loop just for doing it. We've got some integer we want to move across a range, doing multiple things. That's great. So now I'm going to come in here and put next. Ultimately, I'm going to get rid of all of these statements except for just one. But kind of while I'm doing this development, I'm going to kind of think about this is going to be, I'm going to put I for all of these, just as I'm making the conversion. All right, now I got to get this thing to go 10, 9, 8, 7. So what am I going to do here? 11 minus I. Excellent. Outstanding work. Give yourself a gold star for the day. 11 minus I. And I do that replacement on all of these. And now I look at those lines and I realize, yeah, mission accomplished. These lines are now exactly the same. And so I can put that as the target of my loop. And we're sitting pretty. There's one other little problem we're going to have to deal with here. And I'm pretty sure this is the way I have solved this problem for more than a decade. And I don't think I've ever realized this is a potential problem. What is going to happen, right? Because let me get rid of this A here. We can get the length in here. And let me just, I'm going to print checksum right here. debug.print checksum. Now, if this is working right, we should expect that to be 130. They've given us the result on this first step. So this now, when I run this, it should print two things. It should call this function. It's got to run the function to figure out if it's true or false. But on the way to running it, it's going to print this out. And so it should print some value for checksum, and then it should print true or false. Oops. I'm going to run this line, hit enter. Good news. We got 130. That's what we were after. And then it printed true. But what's going to happen if I have an X right here? Is that X going to make it past this first check? Yeah, it's going to be the right length. And I am suspicious that that's going to be a problem doing this math with an X in there instead of a number. So let's see what happens. Yeah, it doesn't like it. I get type mismatch. Type mismatch is a frustrating statement when you're first doing this, because what does that even mean? Type mismatch means that you're trying to do something with a type that doesn't, it's not allowed to do. I'm trying to multiply a string X times a number. Well, it's always a string because I'm using the mid. Mid returns a string, but the VBA interpreter says, oh, you're trying to multiply by a string. Before I give up on that, I'm going to see, can I convert it? So it's converting all of our other numbers, but it can't convert the X, and it fails. So I think what I'm going to do right here as well is, let me just do one more look at this. And I'm going to say, if not is numeric, then exit function. If not is numeric, FUN. Someone sees the problem and I don't see it yet. FU, thank you, FUN. So now, instead of trying to do the math on that, we're going to check to see if it can be converted into a number first, because that's what isNumeric does. And if it can't, so if this is false, right? If it's not a number, this will be false. We will convert that to true with the not. So if this whole expression is true, we want to get out of the function. Just drag that back up there and run that line again. And that's letting me out immediately of false before it ever prints the number, because we never calculate it. We're getting out early. So because we're allowing X to come into the ISBN, we're going to have that check in there as well. But it seems like we've made it so far so good. So that's step one. So why don't I just kind of mark that here, step one. That'll help me as I'm working this out. So what's step two now? So here's step two. So it looks like the next thing we're going to do is we're doing this 130 mod 11 is the next step in here. So I'm now on step 2. And I could have like another variable to keep track of this. But the truth is, checksum, I can just kind of keep modifying checksum as I go along, kind of the same way that we're seeing it happen in this example here. So it's just, we're changing it as we go through. So I'm going to go ahead and just reuse checksum here. Okay, checksum is going to be equal to its current value, 130, mod 11. I think we just say mod. It actually is the keyword mod here. So if I take 11 mod 5, that should give me 1. Yeah, because I can divide 11 twice by 5, and that would give me 10, and with 1 left over. So I'm now getting the result here. Let me go ahead and print the checksum there. I'll run this, and we'll check to see if we're following along with the example. You got to get the X out of there. Was that a number, or did I add an X? That was a number. 306. Okay, so looks good. So returning true. Of course, it's returning true. If it makes it past this check here, it's going to return true because I've got that hard coded down here. But looks like 9 is the next step. Yeah, that part comes down here to 9. So now here's the next part that we're doing. We're taking 11 minus that number, and that should give us 2. So do step 3. We're going to say 11 minus the checksum. And then print the checksum off again. Let's see what that gives us. That's giving us 2. Yep, so we've got that part coming here to be this 2. And then our last step, well, our second to the last step, the penultimate step is to take this mod 11 again. So step 4 is what we just calculated. We've got that in checksum, mod 11. That's what we've got here. So we'll check this one. We're getting down to 2. Now, where does it tell us that if it's 10 as a result, we got to switch it? I don't know. But I think if memory serves, if not, we'll have to Google and find an ISBN, but I think 1, 2, 3, 4, 5, 6, 7, 8, 9, X is a valid ISBN. I think that should have a check digit of X. Let's just see if this prints 10, then we'll know I got the right ISBN. If not, we'll have to look one up. Okay, good. Yeah, so for that ISBN, the check digit should be 10. So, but of course, we've got to convert 10 into X. So we can't just plug that into checksum because checksum is a number. So we can't just take it as X. So why don't we handle it this way? At this point, let's do this. We've calculated the checksum. Let's say an if statement here that says if our checksum is equal to the last character of our ISBN. So our last character is what is holding our check digit. So the right of ISBN. Okay, so checksum. If that's true, then we're going to return true. Or if my checksum, put this in parentheses, it's going to be complex. If my checksum is equal to 10 and my last character is X, that's another way I could get to true. And the rightmost character is equal to X, but I'm going to force that into lowercase and put L case around that. Then will return true. We could say else return false, but if we never hit this line, it's going to return false. Ooh. I think that is the algorithm. I think that will validate an ISBN according to the parameters that we've specified. So I really don't want my function printing that. They get rid of the print. So I got rid of that debug.print statement. So this should now just return either true or false without setting anything else. If checksum right. Oh, I got to say how many characters. The right one character. The right one character. That's true. Now, if I change the check digit to any other number, that's going to return false. I guess we don't have to prove it to you by doing them all. Let me take this back to X. But if I come in here and transpose any of these two, it's going to return false. It has to return false because that's the nature of the algorithm. The algorithm is designed to be able to detect those kinds of changes. Whew. How comfortable are you with the stuff that we've seen so far? 0 to 5. 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. Just making me feel like a great teacher. Let's go ahead and plug in a couple of ISBNs. I wonder if I can get a list of ISBNs somewhere. Ooh, 10-digit ISBNs are getting harder to find. List of 10-digit. Oh, wow. That is creepy to me. Example of 10-digit ISBN, search for books, A books, list of registered groups, and those pesky X's. Rochelle is going to tell us all about those pesky X's. But is she going to give us some numbers to validate? I don't know. No, thank you, Rachel. Take my word for it, it works. Now, as it turns out, we've got a project that's almost just like this. What's the difference? Have you looked at the project yet? Yeah, so this is the old standard 10-digit ISBN. When the ISBN was invented, it was just for books. Then, I want to say early 2000s, we've got barcodes and numbers identifying all kinds of products now. And so they thought, you know what would be great if ISBN could just be like in the same space. In fact, now that you know a little bit about this, let's see if we can find converter for 10-digit ISBN, 13-digit ISBN. I want to find a book that has both the 10-digit ISBN and the 13-digit ISBN. I want to see the ISBN for the same book. If you've got a book of the right age, there was a while that we printed both of them on the back of the book. What you're going to find out is, we look at this one right here. Oh, this will be kind of a fun exercise. I'm going to take this one. Now, in this case, the check digit is calculated based on like these 9 characters. Is that 9, 10, 11, 12, 13, on those 9 characters. But that number right there, that's the identifier for the book, whether it's a 13-digit ISBN or a 10-digit ISBN. That is the identifier for the book. The check digit will be different, and you'll get these other 3 characters on the front if it's 13 digits. So let me just print the checksum again here at this point. And I'm going to feed in these 9 digits. And I'll put an X on the end. So that tells me that the check digit for that should be 5. So that is the 10-digit ISBN that corresponds to this 13-digit ISBN. So it's a different algorithm to calculate this. And of course, it's calculated across all of the preceding 12 characters. The one thing that's different about this that we haven't seen yet in class, and I'm giving you some notes in the assignment, is the algorithm for this, you treat characters differently depending on if they're an odd or an even position. So for the 10-digit ISBN, we treat everything exactly the same, right? We take this digit and we apply the algorithm to it. This digit, apply the same algorithm. For the 13-digit, it's different if it's the first character or the second character. So the first, third, and fifth characters have the same algorithm applied, and the second, fourth, and sixth character have the same algorithm applied. So how would I be able to tell the difference? How would I be able to tell? Now, of course, here, if I've got some loop here, I is going across all of that. So if I could just tell the difference, if I could look at I and tell if I is odd or even, I'd be able to have an if statement that I could use to determine which algorithm to apply to that character in the algorithm. So any thoughts? How could I tell if a number is odd or even? Ah, yes. If you just take a number and you mod it by 2. So if I print, 5 mod 2, like any odd number is going to give me a remainder of 1. Whoops. And any even number will give me a remainder of 0. So by using mod and looking at the index of, not the number, that'll tell me if the number is odd or even, but if the position of that number is odd or even, then I could decide how to treat that particular character in calculating the algorithm. That's the one conceptual step that you've got to figure out how to do differently, and kind of understanding that mod can help you tell if it's odd or even will get you there. Questions? Let's call it good for today. I have nothing more to say. Class, I do. Class dismissed. That's what I have to say. You're too kind. You're too kind.